All right, guys, here we go. This is the last video, going over the last 4 questions. This time we're asked to solve an inequality using the graphical method. And these inequalities are quadratic inequalities because they're all quadratic expressions here, right? This one over here, you notice that it's a little bit different shape because it's not comparing to something to 0. But the way we were going to deal with it, we're actually going to move this over to that side to have one side 0. Or alternatively, you could move this to that side to have it compared to 0. Okay, so let me just give you a big picture overview of what's happening first. So big picture overview, you're going to graph some quadratic, right? And it's going to either open up or down. And it either crosses the x-axis or it doesn't. But in general case, it's going to cross the x-axis. Sorry, that wasn't straight. Try that again. So generally, it looks something like this. Right, you got a quadratic parabola here. And then you're solving inequality. So when you're solving inequality, you ask yourself, okay, let's imagine this thing right here. Let's say this is the picture for this quadratic expression. And I want to know, when is it greater than 0? So I just look at this thing. When is it bigger than 0? When is it above 0? Over here it's above 0. And over here it's above 0, right? So basically the y values are above 0. That's what you're looking for. And so those would be the positions where the solution is correct, right? Everywhere where this thing is bigger than 0, above the x-axis. And then let's say this was switched around where it's less than 0. Okay, in that case, then you would want this bottom side instead. That's where it's less than 0, right? Now, sometimes you have a graph, a quadratic expression or equation where it doesn't cross the x-axis, something like this, say. In that case, the whole thing is greater than 0, right? It's always greater than 0. Or something like this where it opens downwards, something like that would be always less than 0. Okay, let's tackle the first question. So first question, we're given this thing, we're asked to solve it by graphing. That means the first step is to actually graph the thing. And to graph the thing, we're going to change it to vertex form. So we're going to do the usual procedure here. Look at number 16, right? Got to figure out my h, which is negative b over 2a. And then my k, which is the function value at negative b over 2a. Here a is equal to 1 and b is equal to negative 2. So that makes h negative of negative 2 over 2 times 1, which is positive 2 over positive 2, which is just 1. So that's nice. And then k is going to be f of 1. That means I'm going to look at this function and stuck in 1 wherever I see x. So here it's going to be 1 squared minus 2 times 1 minus 3. 1 squared is 1 minus 2 minus 3. 1 minus 2 is negative 1 minus 2 is negative 4. So k is negative 4. I don't even need to finish vertex mode. Actually, I have all the components to graph, so I'm just going to go ahead and graph. H being 1, that means I'm going to go 1 to the right. And k being negative 4 is going to go 4 down. 1, 2, 3, 4 down right here. Okay, good news is this is a nice set of values because when you graph this thing, right, a is positive 1, so that means it's the usual thing. If I go left 1, I'm going to go up 1. If I go right 1, I'm going to go up 1. And if I go left or right 2, it's going to go up 4. So that's good news because it's going to, since I started 4 down, it's going to actually cross right there at that nice point. So here's my parabola connecting the dots, something like this. And this point right here, that's the point 3, 0. Here's the point negative 1, 0, right? So now go to answer my question. When is this thing bigger than 0? It's bigger than 0 for this section and that section. So what are those sections? And the answer to that is the answer to my question. So the answer is, where is this bigger than 0? From negative infinity, right? All the way to the left, up until I hit negative 1. And also from 3 onwards. Right, those are the 2 spots. Notice I'm using the open parentheses because my inequality is strictly greater than, not including where it is equal to 0. That's number 16. This was number 16. Forgot to write that question number. Okay, that one's done. 16 done. Let's move on to the next question. Let's try to see if I can wrangle some of these guys and delete them. Oh, no, too close. Okay. Okay, on to number 17. Okay, 17, same idea here. And nice thing is already set up for me nicely where 0 is on one side of my inequality. So I'm going to go ahead and graph this thing. And to graph the thing, first I want to know what my h is, which is negative b over 2a again. And k, which is the function value at negative b over 2a. Here a is equal to 1 and b is also equal to 1. So h then is negative 1 over 2 times 1, which is a negative of half. Okay, all right. So what about k then? K is going to be f of negative a half. That means I stick that thing into my equation here, this equation here, right? So that's going to be negative 1/2 squared plus negative 1/2 minus 2. Okay, that's negative half squared is positive 1/4. This is minus 1/2 minus 2. Well, 1/4 minus half, that's negative 1/4. And I'm going to change the 2 to negative 8/4 because then I can add them easier. That's negative 9/4. Okay, you can also just use a calculator for the computational portion. Okay, but I get negative 9/4. All right. Okay, so now I'm ready to graph this thing. I've got my vertex, negative 1/2, comma, negative 9/4. And because I'm dealing with fractions, I'm going to make my tick marks quarters, and I can draw things on exact tick marks. So it's going to be 1/4, negative 1. Actually, let me go left first. So negative 1/4, negative 2/4 is just negative 1/2, yeah? I'll go through just to show the scale. This is negative 1. So negative 1/2 would be right in that position. And I'm going negative 9/4 down. So 1, 2, 3, 4, that would be negative 1. 5, 6, 7, 8, that's negative 2. And negative 9/4, okay? So my first point is negative 1/2, comma, negative 9/4 right there, yeah? And then I'm going to go right one, up one, because A is 1. So right one would be actually 4 tick marks, and up one would be 4 tick marks. So 1, 2, 3, 4, over here, something like that. And then same thing for the other side. So 4 tick marks that way, 4 tick marks up that way, something like this. I know it's not perfectly accurate, but something like that. Okay. Ooh, it's a little squiggly, but you get the idea. All right, so that's the picture, and we're looking for where it's bigger than or equal to 0. So essentially the same thing as last time. Let's change to like blue better. So I'm looking at this area, this time also including that point because it's a strict greater than or equal to 0. And this, and also including that point. But to solve this for real, I need to know where that x-intercept occurs, right? So I need to find the x-intercept. So I need to do a little extra work. Let's use green. And find the x-intercept, which is where y is equal to 0. Which is where I'm going to solve this equation, x squared plus x minus 2 equal to 0. And we're going to bust out our trusty quadratic formula to solve that thing. Quadratic formula says x. Quadratic formula, by the way, is only really useful if I'm looking at where it's equal to 0. That's what it's used for. So negative b, which is negative 1, plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times c, which is negative 2. This is all over 2a, which is 2 times 1. Okay, let's simplify a little bit. It's negative 1, plus or minus square root of 1, minus 4 times negative 2 is 1 plus 8, which is 9. And this is all over 2. So that's negative 1, and square root of 9 is 3. So negative 1 plus or minus 3 over 2. And that turns out to be nice. Negative 1 minus 3 is negative 4. Negative 4 divided by 2 is negative 2. Or if I do plus 3, it's negative 1 plus 3 is positive 2. It turns out to be positive 1, okay? So that means this crossed. And, oh, shucks, I should have actually been able to figure that out, really. But that's okay. This crossed at positive 1 comma 0. So it's a nice number. And I did figure it out. I just did the algebra way. Yeah? Negative 2 comma 0. That's weird. So these are those green points right there. Nice points. Okay, so that's good news. That means my answer then is just the positive parts, right? Where the graph is shaded in blue. So it's going to be negative infinity up until this x position, which is negative 2. And this time, I'm going to use a hard bracket because this is greater than or equal to the sign. So it includes the spot where it is equal to 0. Okay, and similarly, that's either that or it's going to be from that positive 1 position up until infinity, like that. Okay, so that's 17. 17 done. It's not working well. All right, I'll just do the old-fashioned eraser way. I don't know where that box was ending for that set of questions. All right, just fast forward me erasing. Skip ahead 10 seconds, maybe 20 seconds, I don't know. Let's get on with it. Okay, we got 2 more to go. Number 18. Okay, number 18 is x plus 6 greater than 5x squared. First thing I'm going to do is move things to the opposite side. So move all things to one side. Wait, hold on. Oh, sorry guys, hold on 1 second. Okay, anyway, sorry about that. Okay, let's continue. So 18, first thing I want to do is just move everything to one side. And I can pick which side I want. I can pick either side, actually. So let's see. Why don't we just move everything to the left? Because we're kind of used to things being on the left, yeah? So if I move everything to the left, how would I do that? I would subtract, so I'd have negative 5x squared plus 5x plus 6 is greater than 0. Yeah? Okay, so from this point on, it's going to do the usual thing, and I'm going to just find my h and k. So h is negative b over 2a. Okay, I was just thinking, I paused for a second because I was thinking, if you want, you can simplify this if it's possible, but there's nothing that really factors nicely because these are 5s and that's a 6. If they're all 5s, I could actually have divided the whole thing by 5 and I'd still be able to find my solution, but it's not quite that nice this time. So a is negative 5 here and b is positive 5. Well, that's actually going to turn out nice because h is going to be negative 5 over 2 times negative 5, right? So h is going to be then negative or negative becomes a positive, so it's going to become a half. And k is going to be f of 1/2. Okay, so what is f of 1/2? So I'm going to plug in a half into this equation here. I've got negative 5 times 1/2 squared plus 5 times 1/2 plus 6. That's negative 5/4 plus 5/2 plus 6, which is 5/4 positive plus 6. You can use a calculator for this portion. And what's 6 in terms of fourths? 6 times 4 is 24. 24 fourths. So I get 29 fourths. Okay. And then that's my vertex. So I'm ready to graph already. Okay. So 1/2 is the h position. This time, let me approximate this. 29 over 4, that's going to be 5 and, sorry, no. It's going to be 6, 7. 7 times 4 is 28. Yeah, 7 and 1/4. So I'm going to go by just regular ticks because that's kind of big. So let's see, 1/2 be halfway to the 1. And then I'm going to go up by 7 and 1/4. So 1, 2, 3, 4, 5, 6, 7, and 1/4. So a little higher than that at 1/2. So around here. It's around here. Yeah. My a is negative 5. That means the thing is starting here and it's opening downwards. And negative 5 means negative 1 to the left, and it's going to go down by 5 already. So 1, 2, 3, 4, 5. Somewhere like this. Something like this. So pretty sharp angle. Something like that. And I'm looking for where it's bigger than 0, right? Bigger than 0. So it looks like I'm looking this time for this middle section right here. That's what I'm after. But in this case too, I still got to figure out what my x-intercepts are, because I need to know where it's going to turn right from positive to negative, where it's going to turn from above to below. So what are my x-intercepts? That's when y is equal to 0. We've got negative 5x squared. I'm looking over here right now. Negative 5x squared plus 5x plus 6 equal to 0. To solve that, plug into my quadratic equation. Negative 5 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Yeah, this is like calculator work here, but see how far I can get without calculator. No, not really particularly good at computation, so I'm just going to cheat actually. Because I don't know if I'm feeling lazy. So 25 plus 4 times 5 times 6. 145. Okay, 145. And turns out that's not a nice square rootable number. It's close, almost is. It's almost 144, yeah. And this is negative 10 on the bottom. Okay, so I'm gonna just give approximations here, okay? Decimal approximations here. I've got negative 5 plus, let's do actually minus first. Minus the square root of 145. And then divided by negative 10. That's about 1.7. Okay, that's the top side. That would be this guy over here probably. And then the other one, if I do plus, it's negative 5 plus the square root of 145 divide by negative 10. And that's 0.70 about. I just did one. Actually, I'm only doing one decimal place, yeah, for that first time. So let's just do one decimal place. Okay, so about 1.7 or 0.7. And yeah, that kind of checks out to where my graph ended up being. So now which one do I want? I want in between these two. So the answer, because that's looking at my graph, that's where it is, right? So the answer is the interval from, oh, wait. Sorry, one of these was supposed to be negative. Oh, this one, sorry. This one's negative. This is negative. Negative 0.7 up until positive 1.7, approximately. This is an approximate answer. And this time, open brackets because this is a strict inequality. Yeah, so okay, now it's done. All right, one more to go, guys. One more to go. Okay, this last one, first time we have a less than symbol. And so we just want to look for where it's below the x-axis. But otherwise, steps are going to be pretty much the same. I'm going to start by graphing that thing. Okay. Okay, let's graph this thing. So we're going to change the vertex form first. So h is negative b over 2a again. Oops, that looks like an h. Negative b over 2a. K is f of that. A is 1, and b here is negative 4. So this is going to be negative of negative 4 over 2 times 1, which is 4 over 2, which is 2. Very nice number. And then f of 2, that's 2 squared minus 4 times 2 plus 2, which is 4 minus 8 plus 2, negative 4. Negative 4 plus 2 is negative 2. Yeah. Negative 4 plus 2 is negative 2. Yeah. Oh, okay. This looks like an easy one to finish. The last two questions are pretty ugly with, or the last one was ugly. The one before that actually was pretty nice. It turned out to be. But this is more like the first one. We're starting at 2, negative 2. Right here. And, maybe not so nice actually. Okay, so 2, negative 2, and a is positive 1. So that means I'm going to go right 1, up 1, right here. And then it's going to continue up like this. Continue like that. Right? Something like this. Okay, and this time I'm after where the thing is less than 0. So I'm after this bottom portion here of my parabola, right? Looking at that bottom portion underneath. Still need to figure out what my x-intercepts are. So to do that, I'm looking for when y is 0. And I'm going to check this thing out. X squared minus 4x plus 2 is equal to 0. I'm going to plug into my quadratic formula. Negative b, which is negative negative 4, which is positive 4. Plus or minus the square root of b squared minus 4ac all over 2a. Just 4 plus or minus square root of 16 minus 4 times 2 is 8. That's square root of 8 over 2. And square root of 8, that's 4 plus or minus 2 root 2 over 2. Okay, and then that simplifies a little bit more because they're all divisible by 2. That's 2 plus or minus the square root of 2. Okay, this is a nice form. There's no sense to get a decimal approximation here because it's already in a nice form. It's either 2 minus root 2 or 2 plus root 2. Right? Those are the two answers for x. So now my final answer, I want the interval between those two things. So I'm looking at 2 minus root 2 up until 2 plus root 2. That's my interval. Okay, there it is. Now, you notice sometimes I answer with the decimal approximation. Sometimes I did the exact answer. Just pay attention to, it didn't specify the format of my answer, so I had that freedom. Normally in a question, look for what it says. If it says exact answer, write exact answer. If it says decimal approximation, then you do decimal approximation. All right, guys, that's it. Thank you for sticking with me. Hope you have a good day.